In this video, we will address the solution to problems related to the indoor unit fan of MIDEA air conditioners, identified by the error code E3. We will focus on 6-wire fans, composed of 2 sets of connections, 3 thin wires and 3 thick wires. These fans operate with a Hall effect sensor, and do not require a relay. 1. If the fan exhibits issues, such as not spinning or spinning slowly, the first thing to do is to manually spin the fan blade, with the unit turned off. Check that the rotation is smooth, with no obstructions or unusual noises, to rule out issues with jamming or bearings. 2. Turn the unit on and see if the fan starts. If it doesn't, try spinning it quickly by hand. If the fan begins to spin normally after being helped, it is likely that the capacitor is damaged and needs to be replaced with one of the same specifications. 3. If the previous diagnosis was inconclusive, the next step is to visually inspect the connection to the electronic board and the fan capacitor, which will require opening the unit. 4. It's essential to remember that a capacitor stores energy. Touching the terminals of a charged capacitor is similar to touching a live household socket. 5. Before performing electrical tests, discharge the capacitor. Ideally, use a discharge resistor, but you can also do it by shorting the terminals with wires or an insulated screwdriver. This process may generate a spark. 6. With the capacitor discharged, measure the capacitance of the capacitor using a multimeter set to the microfarad scale. The value obtained should be very close to the one indicated on the capacitor's label. 7. If you don't have a multimeter or it doesn't have a microfarad scale, you can perform an empirical test by charging the capacitor by connecting it to a lower voltage source than it supports, then discharging it quickly and observing if a spark is generated. 8. If the capacitor is in good condition, measure the resistance between the pairs of thick wires from the motor using a multimeter set to the ohms scale. Check the resistance between each pair of wires. No measurement should be 0 or infinite. If any are, the motor needs to be replaced. 9. To test the speed sensor or Hall effect sensor, disconnect the thick wires from the fan to the electronic board, power on the electronic board, set the multimeter to the DC voltage scale, 20 V, and measure the voltage between the pairs of thin wires from the fan, such as white and green, white and black, and green and black wires on the board. When the measured voltage is 5 or 12 V, stop the measurement. The wire where the red multimeter probe is will be the sensor's power supply, and the black probe will be ground. The wire without the multimeter probe is the speed sensor signal wire. 10. If there is proper power, 5 or 12 V, to the fan sensor, manually spin the fan and measure the voltage on the signal wire. To do this, place the red probe on the signal wire, and the black probe on the ground. The voltage should change as the fan is manually spun. If there are no changes in the measured voltage, the problem lies in the sensor. 11. If in step 9, with the electronic board powered on, you cannot find the correct DC power supplied to the sensor, 5 or 12 volts, through the thin wires, the issue is with the electronic board. 12. You can also measure, with the board energized, whether AC voltage is reaching the fan motor through the thick wires when the unit is turned on. If this power voltage is not present, the issue lies in the electronic board, probably in the triac.